Now in this part of the video, we're gonna calculate the pH of a weak base. We have seen in series of base, strong acid and mixture of strong acid. Now we know weak base. Whenever we talk about the weak base, it must be having a value of Kb, right? And concentration must be given. So we already know the Kb and C. So now let's see, there is a weak base BOH which ionize into B positive and OH negative. So at type T equals to 0, it was C, and when equilibrium has been established, C1 minus alpha, equilibrium C alpha and C alpha. So we know we can write the Kb as concentration of B plus and OH negative and BOH. So B plus is C alpha into C alpha upon C into 1 minus alpha. So Kb turns out to be C alpha square upon 1 minus alpha. Now if we see the number, if you remember the number, if you neglect the alpha, if we are neglecting the alpha, then we are considering the alpha should be less than 5%, 5 into 10 to the power negative 2. So here Kb by C comes out to be less than 25 into 10 to the power negative of 4. So if this Kb is less than it, then we can 1 minus alpha can be neglected with respect to 1. So here alpha Kb equals to C alpha square, 1 minus alpha is neglected, alpha comes out to under root of Kb upon C. Now alpha comes out to be Kb upon C. So concentration of OH negative is C alpha, C into under root of Kb upon C. So it is under root of Kb into C. So that's how we do calculate. If Kb by C is greater than 25 into 10 to the power negative of 4, then we know that Kb was written as C alpha square upon 1 minus alpha. Now we do calculate the alpha, and then concentration of OH negative comes out to be C alpha. So let's try to figure out the one problem. Calculate pH of 0.1 molar NH4OH solution. So we know C and NH4OH Kb value must be known to us, means must be given in the problem, that is 10 to the power negative 6. So concentration of OH negatives comes out to be over the root of Kb upon C. So that is Kb 10 to the power minus 5 into C 10 to the power minus 7. So it is 10 to the power minus 3. So pH equals to 11. pH is 3. POH negative log of is 3 and pH is 11. Now one more problem we have given to us, like how much CS3NH2, right, that has been given, Kb value is given, should be dissolved in 5 liter to water to make such a final solution, and this is called methylamine, right, contains that much moles of H plus ion. Now we have given a base, we have given a Kb, now concentration is being asked, and the OH negative concentration is given to us. So first of all, is it a base, methylamine? It don't releases OH negative in water. So how it is a base? We have seen all the organic bases contain nitrogen. All the organic bases. So how nitrogen gives OH negative in the water? So whenever you dissolve in the water, CH3NH2, whenever you dissolve that in water, it gives CH3NH3 plus it gives OH negative. So concentration of H plus comes out to be is given to us now, and that's how it gives the water. That's why it is called the base. Now how do we calculate the concentration of H positive? So H positive, moles of H positive is given, and volume of the solution is given. So concentration is moles per unit volume, 5 into 10 to the power minus 11 moles in 5 liter water. So H plus concentration coming out to be 10 to the power minus 11. And similarly OH negative is Kw over H plus. So Kw value we know 10 to the power minus 14 divided by H plus is 10 to the power minus 11. So OH negative concentration comes out to be 10 to the power minus 3. And Kb is given 10 to the power negative 4. So 10 to the power negative 4 concentration is given. So we know, we have, if you remember, if you are following one series, that you must be remembering that we have done a problem in which OH concentration is given and we were confusing, like, if you remember very well, then how do we know C, alpha and Kb? All three terms are there. So it was a very confusing system. Then we find out a solution. We could write Kb, right? Kb is, C alpha square upon 1 minus something now in that. Now we have concentration of OH negative, we have Kb. Now we don't have alpha and C also. Now to come out next expression, what we did it as C alpha into alpha. We could write, okay, C alpha and square, we can separate it like that. C alpha into alpha. Now C alpha is the OH negative concentration into alpha upon 1 minus alpha. We could write OH negative concentration is C alpha, right? So Kb is 10 to the power minus 4. OH negative concentration is 10 to the power minus 3 into alpha upon 1 minus alpha. So by solving that, alpha comes out to be 1 over the 11. Now we know alpha, it is 1 over the 11. Now how do we calculate the, what we are asking, calculate the, what should we do? The amount of ammonia, methylamine has been asked. So we know alpha, so the C alpha, we know the OH negative was C alpha. So C alpha is 10 to the power minus 3. We know alpha, so C into 1 up over 11 equals to 10 to the power minus 3. So C comes down to 11 into 10 to the power minus 3. Now weight here is concentration multiplied by molarity multiplied by volume. Consider 11 into 10 to the power minus 3. And molarity. Concentration is that, and molar mass, sorry, M stands for molar mass. So methyl amine has a molar mass of 31 into 5. So that comes out to be actually 1.815 gram.